Welcome back to Excel. This lecture is on using data and analyzing data and using statistics for our analysis. As engineers, this is very important for us. We use statistics in a lot of our analysis of data. We are always analyzing data to figure out how to make things better or how to do anything with creating a new design or anything. So why do we do this? Why do engineers gather data to measure? Why are we doing it? Some reasons are we're looking for data to see if we're getting any variability or consistency in our data. If things are looking good, we aren't having a lot of variability. We're having real consistent data. Also, data analysis allows us to really understand a data set. It allows us to compare one set of data with another set of data. As an example, you may be working on a manufacturing line and there's some defects that are coming out of the line. The parts have changed size over time, you're noticing. You may see that there's a specific dimension that you're looking at, and that dimension may be 6 inches or something. And over time, that starts to get larger and larger, and you're wondering why that's getting larger, right? And now you're starting to see failures. And if we compare our data set of the first parts that were made and worked perfectly to data set that maybe is 2 years later, we see that that value has changed. So it's good to look at the average of that kind of thing, or just general data itself. And this could be due to maybe tool wear in the stamping die or something like that. Could be causing this change in the size. But as engineers, we need to really be meticulous and careful and really analyze everything to really understand it all. Okay, and we can use statistics to analyze our data, help us analyze it. So what are some common parameters that we look at when we think of statistics? I'm sure a lot of you know a lot of the basic answers to this. There are many different types of parameters. The ones that we kind of want to look at really are mean. And mean is also another word for average. And we've talked about average before. It kind of gives us this average size of something. Or we also talk about mean, right? There's also something called median. And the median is the middle of our data. Mean and median are not the same thing at all. They are completely different, right? The median is the middle of all of the data set, and the mean is the average of the data. And we'll look at this in more detail coming up, as we will with mode and min and max and variance, standard deviation, and range. We'll look at all of those individually as we go through this lecture. So the most common one that we talk about typically is mean. Right, it's the most commonly used characteristic of a data set, right? And the mean really refers to the average or arithmetic average, right? And it indicates our expected behavior. We expect most things to be around our mean, right, or our average. And how do we find it? Well, in Excel, we use a function called average. And we have this function average, and this function has the arguments of some range of data or data set, individual pieces of data, and it can add up all of that data, count how many data pieces there are, and divide by the total, giving us this average. And you know, I give out exams and things like that, and other instructors do also, and we give you this average, right? That kind of tells you where you fall compared to everyone else, right? We expect that you will be, most people will be around this average value is how it works. Let's look at how average works in Excel. Okay, so here we are with our engine cylinder data. This is some measurements that were taken on the diameter of a cylinder, and we have 20 different samples that we're looking at. Okay, and if we want to find the mean, or the average, we type in equals average, open parentheses, oops, not close, but open, and I could select each one individually, or I could select on the first one. I'm holding my shift key down, selecting the last one, and then closing the parentheses. And this will give me the average of all of the data. All right, let's go on. Okay, next is median. Median is really, if we're given a set of data, it's half the values lie above it and half the values lie below it, of this median value. All right, so it's the middle of our data. Think of it as just the middle of the data itself. Okay, and how do we find it? The way we do it is if we have an odd set of data, an odd number of data sets, the median is the middle set of that data. If we have an even number, the median is the average of the two centermost values. And I'll go through an example by hand on how to do both of these in a minute. In Excel, how do we find median? Median is found by using the function equals median and then a range of values. And it will return the median value. It's very simple to use. Let's look at it by hand how it's done. Okay? So here's the first example of an odd set of data. We have this set of data 3, 2, 8, 5, 10. And if we look at that, we want to look at the middle part of that data. The first thing we need to do, though, is order our data set from smallest to largest. So 2, 3, 5, 8, 10. And now we will find the middle of that value, right? So here's the outer two most, the next one, and here's our middle value. So our median in this case is 5. That is the middle of our data, the median. So half of the values are below and half the values are above. That's all it means, right? But this is not the same as the average, right? It's not the same as the mean. If we look at the mean or the average, it is 5.6. It's up here a little higher. These values of 10 really bring the average value up higher. So it is not the same, and it's typically not the same. So a lot of people, if you listen to the news and things like that, or someone trying to sell you something or whatever it might be, always listen to what they're saying. Sometimes they may say average or median, or they'll say median, or sometimes they'll say mean, or they'll say average. Those are not all of the same things. Of course, mean and average are, but median and average are not. Right? If we have an even set of data, let's say we have this set of data, we have 4 pieces of data. We again reorder our data sets. We have 2, 3, 5, 8. And we know if we look at this, there is no middle value here, right? There is nothing in the middle here, right? So we don't know what our median is. If we know what our operation is to do that, we select the 2 most middle ones, which are 3 and 5, and we take the average of those. And that average, if we take that, is 3 plus 5 divided by 2 is 4. 4 is the median for this set of data. Again, this is not the mean of this set, right? Again, here the mean in this case, if we add these up and divide it by the number of values, is 4.5. So again, it's still higher than our median. They are not the same value. Okay, so let's take a look at how we do this again in Excel. Okay, here we are back in Excel, and to do this we do equals and we type in median. Open parentheses. Oops, that's the closed one again. I'm always getting that wrong. I'm just holding the left mouse button down and dragging it. I can do it that way also. Shift and close parentheses, and we have our median. So at 3.501 is the middle value, and there's an equal number of engine cylinders larger than that and equal number of cylinders lower than that. And you see that is significantly different than our mean, and that's really due to this value here. You see it's at 6, really. That's probably some weird data, right? It's probably more let's just say 3.5 if we do that. Now they're real close, but the average is still different than the median, right? It could be 3.7. Let's do that. Right, now we see that that's a little bit larger. So they are still different. Okay. Let's go back and continue on. The next statistical function that we have is mode. And mode, if we're given a set of data, mode is the value that occurs with the greatest frequency, or it is the one that occurs the most. So think of mode and most. What occurs the most often in our data set is the mode. And data can have multiple modes in it, right? There may be more than one mode. And how do we find mode in Excel? It's a very simple function. equals mode and our range of values. Mode in here will only, though, give us back one of the modes. So if there are more than one modes of data, it will only come back with the very first one that exists. So let's take a look at using this. Okay, here we are again. Now we're going to do the mode function. Again, it's equals mode, and we will select our range of data again right here. All of this data, and it will come out with the one that occurs the most. In this case, it's 3.497 occurs the most. Now, there may be other modes in this set of data, and it's, if you have large sets of data, it's hard to know. But let's look at what happens with this set of data. I've just created this set of data, and we can see easily that 1 is one mode, 4s are another mode, and I have it in this order. So if I do equals mode, and I set this up, and I check, my mode is 1. Okay. I can do this again with the same set of data. I still have 2 4s and 2 1s, but I switch the order and switch the data around a little bit. And now we'll do mode here. And you will see if I do this, our result will be the first ones that it finds, which is 4. So there's multiple modes in this same set of data. Both of these are the same sets of data, essentially. But the mode function will only come back with one result. The next statistical data analysis tool that we have is min and max. And this, again, is a very simple type of function. It looks for the extremities of the data, or the high and the low in the data itself. In Excel, we find it by using the function min and max. Those are very simple. Let's put those in real quickly. Okay, we're back in here. Now we will do the min and max. And you may say, why am I doing this? You know, it's easy enough to look at the data set. I can find that. But the problem is, if you have, you know, thousands of data that you're looking at, this can be very difficult. So that was min, here's max. Again, we're taking all the range. So it can be hard, and this is a very simple way of finding the min and the max of our data. So they're very simple functions to use. Okay, now we're going to look at the spread of data. What does that mean, the spread of data? Sometimes our data, it can be very close or compact around the average or the mean, and sometimes it can be spread out, right? It might be a very large distribution of data, right? And we have different measures of spread, and we have 2 specific ones that we'll be looking at, and those are variance and standard deviation. So let's take a look first at variance. And variance really identifies, again, the spread of the data. So both of these are measures of spread of data. This is one of them, right? It spreads it. The higher the value of the variance, the greater the spread, right? The larger that distribution is of the data. And it can be found using this complicated formula. It's this s squared value equals 1 over n, and then we're summing up some data. We're looking at the difference between the average and the data point itself, and we square that and add up each of those. I'm not asking you to do that. Excel will do this for you. It will calculate the variance for us, which is really handy. And this is the function that we use, this VAR, and that will calculate the variance for us. So here we are. Let's calculate variance. And it's again VAR, and you'll see there's VARP and S and different ones, but I'm just going to pick the VAR. It's an older version one. I've used it for a long time, and I still use that one. So VAR, and it comes back with this result. And notice the units on it squared, inches squared. Well, it's kind of a weird term for us to calculate what a spread means. It doesn't mean a lot to me. I don't know about you. But let's look at standard deviation instead. So again, another method of looking at the spread of something is standard deviation. And again, similar to variance, the higher the standard deviation, the greater the spread. It too has a complicated formula. It's exactly the same formula as variance, except it's the square root of it. That's all it is. It's just the square root of it, right? And it's denoted by this square root sign and using STDEV as the standard deviation. So let's take a look at that. Okay, let's look at standard deviation. So we have equals STDEV, and you see there's a P and an S and all those. There are different formulas. I'm just going to use this plain one and, oops, highlight my data. Oops, I did that wrong. Let's try this again. There we go, and enter. So we'll see that that is our value. And if I look at that, it should be the square root, SQRT, of this value, right? It should be the square root of it. And you see that it is. So we know that that's the right value. Okay? Let's look at what this means. What does standard deviation really mean? So this is an example of what standard deviation is used for. If we look at this, it's a normalized or bell-shaped curve. In this curve, we have this center point of this curve. This is our average or our mean, denoted by a mu. And then we have data on either side. And if we look at this, we can look at one standard deviation called S. We'll call it S, and here's a minus S. And if we look at this red part in here, right, this red section, 67% of the data falls within that range. So if I give an exam and I give you the average and you take the standard deviation plus or minus that, 67% of the class should fall within that range. If I look at two standard deviations, or 2 times S, and a minus 2S, that's the green section and the red combined. That means that 95% of the class should fall in that range. If your exam is not within that range, you're higher than that, then that means you're in the above that section. So if I look at 3 standard deviations, that's 98%, or almost all of the whole class falls within that. You may have heard terms in manufacturing of Six Sigma. Six Sigma essentially is 100% of the data. It's 99.9999, huge amount. And typically what that's talking about is looking at making sure we put out quality parts, that there are no failures, that we get all of the good components out. We get the 100% of good material going out. So that is what standard deviation is, and the higher the standard deviation, again, as the larger the standard deviation means that we have larger spreads. So it could spread out more like this instead, right? It's a much larger spread. Or it could be a smaller spread. So our data could be like this instead, right? So that would be a smaller standard deviation. Okay, so that's what the standard deviation is. So when I return exams, or any other teacher returns them and they give you the standard deviation, you can use that information to determine where you fall within the class. You know whether you're above or below the average or the mean, but now you can kind of know compared to everyone else where you are also. So that's kind of handy. So why do we have these two different ones? Again, if we think about it, the variance gives us a value that is squared. That squared term, if I give you, 5% squared as a variance, that doesn't mean anything. But right, if I give you the square root of that, whatever that value is, 2 point something, 2%, then you kind of can use that information as something that will help you understand where you are in the spread. Okay. The last one I want to look at real quickly before we do something a little bit different yet in statistics is this whole idea of range. And Excel has no range function, right? But you can determine it, and you can determine it using the min and max value. So let's look at that real quickly. Okay, so here we are. We're going to calculate our range. And the range, again, is the maximum minus the minimum. Right? So that is our range. I could have also done max, and I could have written it all out this way also, but I had it up above, but I could do it this way too. Min. Oops. There, and I get the same result. So that is how you have to calculate range. Range is not an Excel function. Okay? Let's go back now. Okay, so is there an easier way to do this than writing all those equations? And the answer is yes, there is an easier way to do that. But we need to use the data analysis tool pack. Your Excel program may have the data analysis tool pack. If not, I will show you how to get it. Let's take a look at how we get the data analysis tool pack if it doesn't already come with it. And it's really under the data tab, and it should say data, should be analysis section, and then the data analysis. All right, here's how we get that tool pack if you don't already have it. Okay, so if we go under File, and we will see Options. From Options, way down on the bottom here, second up from the bottom, on the left-hand side is Add-ins. Click on Add-ins. You will see Manage Excel Add-ins, and we're going to click Go. And from here you will see a list of different add-ins that we can have. Typically the software doesn't have all those in right away, just to save space on your computer and everything. We're going to pick the Analysis Tool Pack and select that and say OK. For some reason it's not letting me get it. Let's take a look at that, see if it already is there. Data. Manage value. I don't see it. Hold on a second. Okay, sorry about that. I just had to relocate and find my .xll file in that. So you do that add-in. So again, you go under File, Options, and then you go to Add-ins and select OK. Mine's already selected, so it's say that and then say OK, and it should find it. I had to browse around and find mine and do a search, but I did find it. I'm not sure why that was wrong. So if you have that problem, you may have to browse and find that file. Okay, so here if we look under our Data tab, I'm on my Data tab, you'll see in the Analysis area here is the Data Analysis. And what we want to do is see if we can find a way to come up with the results that we have here in a lot easier fashion. So if we go here to Data Analysis, here, let's go back to our presentation a second. Okay, now that we've found that, we clicked on the Data Analysis. We want to look at this analysis, so on the Data tab, click the Analysis icon, and then we want to click on the analysis you want, and we want the descriptive statistics. All right, so let's look at that. Okay, so we want descriptive statistics, which is this one here. If I just click on that, I say OK. Another window should open up. And here we have our window, and it's asking for an input range. This is all of my data, so I'm going to select all that data. So you see here's the range for it. And I could put it on a new worksheet, or I'm going to put it on some worksheet here, and I'm going to place it here. Click here, and I'm just going to place it there, and we should be okay to go. I think we want, what do we want? We want the summary statistics is what we really want. And if I say OK, let's see what it comes up with. Here we go. This is the data that we get. Okay, so here we have our mean. You see our mean, or median, our mode. We give some standard deviation, variance, a few other kurtosis and skewness and things like that, which are additional statistical functions that we aren't going to really worry about. And you can see this comes in really nice and quickly. The problem with this, though, is if you look at it, if I double click on it, it doesn't have a formula. It's got a number and a value to it, but it doesn't have anything else. So if I go in here and change this to 20, right, you see that it changes everything in here, but doesn't change anything there. So it's a quick way of doing it, but it doesn't give me the flexibility of changing my input in my data. So there's the negative to that. Okay? Okay, now let's look at if we can plot our data, right? We have all that data. Let's see what the actual data looks like. And one easy way of doing that is to actually use a histogram and then a cumulative distribution. Those are two major ways of looking at the data that we have. This is a typical plot of a histogram. This is the one we will create. You'll see that there's something called bins, and this is the frequency, how often something occurs in that range. If we look at this, pick the green one, this means that there are different bins, right? So this is the 492 bin, which is the right edge. So any data there, this is the 494 bin, this is the 496 bin. And it's saying in this bin from 494 to 496, we only have one data that occurs in that range, and so on and so forth. So let's take a look. How do we create this histogram? What are the steps that we need? What we need to do is first divide our data into intervals, or we call them bins, right? And the first interval must begin at or below the minimum data value, okay? And the last interval, the high one, the maximum one must be higher than the maximum data value. And these intervals are essentially adjacent to each other and a fixed width. So these bins are a specific width. All right. In Excel, we label the right edge of the bin. Okay, so let's take a look at that. And what else do we do? Then we determine how many data values fall within each interval, and it will calculate that for us, right? And it uses something like this. It goes in and calculates how many are in this range and how many are in this range, and sums up the frequency. If we sum up all of them, it'll end up being 100%, right? So that's the frequency of it. We can plot this on our graph, and it shows each of the intervals, the data that we have in each of those bins. Okay, so in Excel we can do this rather easily. Again, going to the data analysis tab, and we can select histogram. Okay, I'm going to do this at the same time. Also, we can also plot a cumulative distribution on the graph, right? And this plot allows the user to estimate the likelihood that the data value associated with an item drawn at random is less than or greater than some specific value. So it gives us the likelihood or probability. That's what that means, is it's a probability. Okay, and this is the formula. Don't worry about that. It'll calculate it for us, all right? We can get both of these at the same time and put them on one chart if we want. Okay, so let's take a look at that. Okay, so first we need to determine our bin, right? So here's our bounds, or we can also call them bins, is the way Excel really does it. And we said our first one should be 3.492. Looking at our min, this is below our minimum amount. The next one, we're going to go in intervals of 3.494. We're going to go in intervals of tens, hundreds, thousands, 2000s, right? And I can actually highlight these two and take them all the way up, and we need to be above our max. So we need to go up to this 510, should capture all our data. So that is our bins and bounds for this, right? Our bins or bounds for this. And now we can create our histogram. Again, go to our data tab, go to data analysis, and here we are going to pick on our histogram. Here's our histogram. We say okay. We want to put this in a range on this sheet. We want an input. This is the input, is all the data itself. The bin range is our bin right here. Those are the ranges of our bins. We can label it if we want. Our output range is going to be somewhere over here, like that. And what do we want to show? We want to show a cumulative and a chart output. Okay, so again we have our input range selected. That's our B data over here. This is our bin range, that's all of our bins, and this is our output, so some place over there. And all we're doing again is using this cumulative percentage and the chart output. And if I say OK, it draws everything for us. Let's take a look at what we have. Let's move over here. So here is our bins. Each of the bins are labeled. Here's the frequency or the number that are in there. So there's nothing in that 0 up to 492 range, up to 494 range. There's 1 there. There's 2 occurrences of cylinders from between 494 and 496 and on up. And it will then create the frequency or the cumulative distribution of it, right? So it's 0%, 5% are there because 1 out of 20 is 5%. And here's our chart. Let me make this bigger so it's kind of more useful for us, right? It doesn't look very useful in this state. Here's our chart. So here it's plotting the chart for us. Here's our cumulative distribution, which is the percentage on the right, and on the left is the frequency or the number of occurrences in each of those bins. Okay, so let's look at how we use this and how we can get the probability of an occurrence happening. Okay, so here's our data again. Here is our chart. And now let's look at this. This is just the distribution of the cumulative distribution part of our chart. So let's just say again, we have a cylinder that is this 3.5 diameter. And if we go up here, we see if we go up the chart, we see it ends up at this point, which is at 55%. What that is telling me is that if I pull out a cylinder at 3.5, there is a 55% chance that it will be that or less. Okay, so anything less than 3.5 inches will be 55%. Greater than that will be 45%. Okay, so this is the greater part, is the 45%. If I have let's say, let's pick another value. Let's pick this 3.504. If I go up here and come across, you'll see I'm at 85%. So 85% of the cylinders will be 3.504 or less, and only 15% will be larger than that. So that's the probability of something. So what's the probability of it being greater than 3.504? 15%. That is how we use this data. All right, I want to look at one more thing, and then we're going to call our quits, and we're going to look back at that distribution curve that we created. And let's just see what happens if we change the bin sizes. Okay, now we're back here. I'm going to create different bins again and just see what happens. Let's call it bins this time. And we're going to start with 3.492, and then I'm going to go 3.494. So I'm going to double the size of the bins and see what our curve looks like. And we need to go to 3.15. So that's all our bins. Let's do the same thing again. We go to the Data tab, Data Analysis, Histogram. We've got our input, which is that, and our bin range. We're going to pick this for our bin range, and our output here. We're going to stick it over here, down here, and we'll keep those same ones selected. If I say OK, here's our new piece of data. Let's see what this looks like. And this one looks still rather similar to the other one. Sometimes you have to play around with them and they kind of change quite a bit. But this one looks relatively the same. Not much has changed. Let's run it one more time, and I'm going to delete this, and we're going to double it again, right? Let's clear this, and let's run these again. Let's do this 3.92, make this 3.48. Let's 98, sorry. 98. Let's make it really big and see if that does something different for us. So we only have a few bins, right? So what does that do? What does that make our output look like? Let's take a look. So again, data analysis, histogram, okay. Output, input is the same. Our bin, let's change our bin to be just that. And we'll leave that the same. And here we go. Let's see what it looks like. So here you see it's kind of, it's not terrible, but it's really not as useful. The other one kind of gives us more of this curve starting out here and then kind of plateauing out. So that's what happens if you have too few bins. But what if you have way too many? All right, let's try one more of those. Let's put one down here and we'll call it bins one last time. And we're going to start out with this 3.492 and then we're going to go 3.493. We're only going to go up by 1 each time, right? And we got to go to 3, 10, somewhere in there, right? So now let's go to our data analysis, histogram. We're going to reselect our bin range. Looks like it knows that's what we want. Let's say, and let's put this somewhere else. Let's put this over here. Where's my chart? Oh, there's my chart. Now let's take a look at what this graph looks like. It's not, the histogram isn't so good because it's really only one data at a time. The distribution one isn't so bad, but this one up, down, it doesn't really give us a nice curve. You can kind of see the bell shape in this. This is kind of flat with just a little bit of up. So there's too many bins. So a lot of times in some of the homework and things, you may have to just play around with the bins to get a nice histogram that looks good, that might give you some meaningful data. Okay? We'll end it there for today. I hope this was informative for you. If you have questions, please ask me anytime. Contact me through the class webpage, and I will answer questions there. Thank you very much, and we'll talk to you in class.